Hello everyone. Today we are going to analyze this propped cantilever beam. In this beam there is a clockwise concentrated movement m which is acting at a distance of a from the fixed end. We know that in the point P the upward deflection due to RB should be equal to the downward deflection due to the movement m. So A1 x1 bar upon EI is equal to A2 x2 bar upon EI. Since in this beam EI is constant, we can eliminate that. Finally, we will get this. Now from the point B and about the point A, we are going to find the moments and to draw the bending moment diagrams. To draw the diagrams, we have to follow left hand side rule. Clockwise will be negative and anticlockwise will be positive. First, let us take RB. It is acting in the anticlockwise direction so that it will be positive and the distance is L. So RB into L, we will get RBL and the diagram will be in the shape of a triangle. Now let us take the moment M. It is acting in the clockwise direction so that it will be negative and the diagram will be in the shape of a rectangle. Now let us find area 1 x1 bar. We know that it is a triangle. We know the area formula of a triangle half into BH. Here the breadth is L and the height is RBL. So this is the area. Now let us find x1 bar. We have to find the centroid distance about the right side. For this triangle, the centroid distance about the right side is 2 upon 3 into breadth. Here the breadth is L, so 2 upon 3 into L. Now let us find area 2x2 bar. We know that it is a rectangle. When we multiply m with a, we will get the area. Now let us find x2 bar. We know that for a rectangle, the centroid lies in the center. So when we divide A by 2, we will get the centroid distance. We have to add the remaining distance, that is L minus A. So A upon 2 plus L minus A. Now let us equate area 1 x1 bar and area 2 x2 bar. We can eliminate this 2 and this 2. L into L into L, it will be L cube. A upon 2 minus A, it will be minus A upon 2. For these two terms, we can take LCM. We can take L cube upon 3 on the other side. It will come inversely. For RB, we will get the expression as 3MA upon 2L cube into 2L minus A. Now let us find RA. In this beam, there is no load. So the values of RB and RA will be same, but the directions will be different. RB is acting upwards, so RA should be acting downwards. Now from the point B, let us take a moment about A and to find MA. RB is acting in the anticlockwise direction so that it will be positive and the distance is L. The concentrated movement is acting in the clockwise direction so that it will be negative. Let us assume that MA is acting in the clockwise direction so that it is also negative. We can eliminate this L and here it will be L square. Let us take minus MA on the other side so it will come as positive. From these two terms we can take M outside. Then we can multiply 3A with 2L minus A so that we will get this. For these two terms we can take LCM. Finally for MA we will get this expression. We have made the expressions for MA, RA and RB. We have assumed that MA would be acting in the clockwise direction, but it can either act in the clockwise direction or in the anticlockwise direction. It depends on the distance A. When we apply the values in the formula, if we get a positive value, that means the movement is acting in the clockwise direction. If we get a negative value, that means it is acting in the anti-clockwise direction. Suppose if the concentrated movement is acting in the center, in these two expressions, instead of A, we have to apply L upon 2. In this way, for RB, we will get 9m upon 8L, and for MA, we will get m upon 8. Suppose if the concentrated movement is in the property end, in these two expressions, instead of A, we have to apply L. In this way, for RB, we will get 3m upon 2L, and for MA, we will get m upon 2.